In this part, we are going to learn about class methods in C++, also called member functions. Okay, so class methods define the actions or behaviors of an object. We will focus only on what class methods are and how to use them with simple examples. Okay, so a class method is a function that belongs to a class. While data members store information, methods operate on that data. So methods are called using an object of the class. Okay, so let us take a look at a simple class with a method. Okay, so right here we can create, outside our main function, we can create a class named car. Okay, like that. Then we don't forget to add semicolon at the end. Then from there, inside our class, we are going to have public. Then we are going to have public. What? Let us have public. Let us have string, which is our string. Let us call it the brand. Okay, so from there, let us have our method. Okay, our class method. Let us name it show brand. It's going to be returning a void. Okay, nothing. Okay, from there, okay, then inside we can output our brand. We can say out. We want to output our brand like that. Okay, so after there we can save. Okay, then the show brand is the class method, and it belongs to the car class, and it prints the value of the brand, and the method has access to the class data. Okay, so let us now take a look at how we can call a class method. So to call a class method, we can go inside our main function and we try to create our first object. Let us name it car1, like that. Then from there we can get access to the brand. We can say car1 dot, we can set the brand to be equals to, let us say to be equals to Toyota, like that. Add a semicolon at the end. Then we can also get access to our method, so we can say car1 dot, we can say show brand, like that. Don't forget to add a pair of parentheses and then semicolon at the end. So after there we save and we try to compile. After compiling, let us try to run. As you can see, we get Toyota out. Okay, so car1 is an object of the car class, and the dot operator is used to call the method. Okay, so let us now take a look at methods with parameters. So class methods can also take parameters. For example, let us create another class. So we have our first class here. Let us try to forward it like that. Okay, so here I've just tried to forward it. Okay, as you can see, I've forwarded it, and I can unforward our class, as you can see. Then we are going to create another class, and I'm going to name it calculator, like that. And this class is going to have inside, let me add a semicolon at the end so that I don't forget. We can have public, and public, let us have void. Let us create add method. Then this add method is going to, we are going to output, let us output a, but before we let us create our parameters here, int a and b. Then we are going to try to output a, then plus b, like that. We add a semicolon at the end. Okay, like that. Then from there we are going to create our calculator object, and we try to call our add method. Okay, and then we call our add method and we provide the parameters that are required. Okay, all the arguments. So we go down here and we create a calculator called the calc1. Let us name it calc, and then we are going to get our calc, and then we say dot. Let us call the add method, and the add method requires two parameters or arguments, the a and b. So let us provide 5 and 3 inside. Then we try to save, and after saving we try to compile. After compiling we try to run. As you can see, we get Toyota and 8. Okay, Toyota and 8. We can try to format our code by doing something like this. We can say that we can call cout here before calling our method, and we say we add end line like that. Okay, like that. We try to save, and if we try to compile, after compiling, let us try to run. As you can see, we get Toyota and even 8. Okay, so the add method takes two values, okay, and it performs addition. Okay, as you can see, the add method takes in two values, a and b, and it performs addition of a and b, and output will be 8 if we provide 5 and 3. Okay, so let us now take a look at methods with the return values. Okay, so methods can return values just like normal functions. Okay, so we can do it like this. So let us create another class. I want you to be comfortable with creating classes. Okay, so I'm going to forward this class. Also, you can leave it and continue on to on the next line, but I like forwarding so that you can see everything. Okay, so let me also forward that class. Okay, so I'm going to create another class, and this class I'm going to name it math, like that. Don't forget to add a semicolon at the end. Then we are going to have public. Let us have first I'm going to explain about public in future parts. Okay, so I'll explain about public. So we are going to have our method called the square. Then this square is going to take in x. Okay, so you should note that this method is going to return an integer. Okay, so from there, let us return an integer. So an integer is going to be the multiplication of x, okay, or the square root of x. So we can get x times x. Okay, x times x, we use asterisk, okay, as the multiplication sign. Add a semicolon, and from there, let us create our first object from the math class. We are going to go down here, and let us try to duplicate this one, copy, and we duplicate so that we move the cursor to the next line. Okay, so from there, what we are going to do is to create our math object. Okay, object from the math class, and then we want to output, let us output the returned value, okay, or the integer that is returned by our m object, okay, from which takes the structure of the math class. Okay, so we can say m dot square, as you can see, and this square takes in one parameter or argument, and let us provide 4. So the square root of 4 is going to be not the square root, yeah, the root, no, the square root, yeah, the square of 4. Okay, or the square. Okay, so 4 squared, or the square of 4. Okay, so 4 squared is going to return 16. So if we try to save and we try to compile, after compiling and we try to run, as you can see, we get, so the square of 4 is 16. Okay, so a square method returns an integer and output will be 16, as you can see here. So let us now take a look at defining methods outside the class. So methods can also be defined outside the class using the scope or resolution operator. Okay, so let us take a look at this. So let us create another class. Let me forward this one, okay, like that, and then I go into this line, and I'm going to create a class. Let me call it person. Let me try to forward this terminal like that. Okay, so that you get a full overview. So here we have our class called person, and don't forget to add a semicolon at the end. Then inside we are going to have public, and this is like an access specifier. Okay, public. Okay, but I'll explain it in future parts. Okay, so we have public. Let us have a string. Let us have name, because the person should have a name, and let us have a function, okay, or a method. Let us name it display, like that. But we are not going to give it a body. Okay, we are going to give it a body right down here. So this one is supposed to be display, like that. So like that. So here our display method does not have a body. Okay, so we can try to initialize or create a body for it outside our class. Okay, so we can go outside our class and we say void, okay, void, and we say person. We want to access our display method, okay, from this person class. Okay, so we can say person, like that, person, and then we add two colons like that, colons, as you can see, we get access to our display method, okay, and even the name, as you can see. So we get access, we write the display, then we write the parentheses, okay, pair of parentheses, and then a pair of curly brackets, okay, to give our method a body, okay. But here right now here we can leave out the semicolon, okay, and we don't provide it, we put it at the end, okay. Then inside our display method, we can write down something. As you can see, if we type C out, can we get access to our name method? Because if we had a body inside here, we could get access to our name method, okay. As you can see, we can get access to our name method. Let us now take a look at when we are doing it outside our person class, okay. Let us take a look at if we can get access to it. As you can see, if I start typing name, as you can see, I get access to the name method, to the name variable, as you can see here, to the name attribute or variable. You can call it anything you want, okay, like that, as you can see. So if I try to save and I try to compile, no, I'm not going to compile because I haven't created a class a person object, okay. I haven't created a person from the I haven't created a person from the person class, okay. So this line, the person colon display connect links the method to the class and helps keep code organized, okay. So let us take a look at why class methods are important. Class methods help us define object behavior, keep code organized, and work with data inside the class, okay. So let us take a look at this last example. Let us try to create object from the person class, okay. So here I'm going to duplicate this code so that we move the cursor to the next line. Let us put it at the end, and let us create an object. Let me name it. This object is going to be coming from the person. Is going to take the structure of the person class, and we say that p1, this is going to be person 1, and we can just declare it like that, and then we get access to p1 dot what dot display. No, let us give it the name. Say the name of the person is Rashid, like that, and we want to set p1. Let us call p1 but dot display, okay. Let us call display, and we try to do that, okay. So this display is going to output our name in the console, okay. So if we try to save and we try to compile, after compiling, let us try to run. As you can see, we get Rashid out, okay. So that's it about class methods, okay. So try to play with them. They are very they are very important, okay, and it's interesting to use them, even most especially this way, okay. So thank you so much.